Today, I think the first item was update on the backend refactoring. So Phil, please take it away. You're muted, Phil.
Yeah, sorry. I think most of it is done. We might do like little tweaks, but the bulk of it is done. I, I don't know what else to say. Um, yeah, so now like just a short overview is the backends are just like passes and our IRs and the IRs are shared by all the backends to sort of like try to avoid duplication and divergence between all the backends. Yeah, we've modified the IR a little bit to accommodate this, but really not much. Is there any question or something?
You had also mentioned using environment variables and changes related to that. Do you want to expand a bit on that one?
Oh, I think that, yeah, this is maybe you're talking about the PR from Microsoft this morning. Yeah, I think we're still like, I guess, polishing how like the out of three backends are going to be integrated. But the backend structure refactor is done. And yeah, that there's the question of how to discover external backends. So I think the goal is for backend developer to not have to change the Triton source code. So this means our setup.py needs to be able to discover their backend from forks, and yeah, and I think we can use environment variables for that.
I'll add, Phil. I think the new code the refactoring looks really good. So like the end result here is quite desirable. I think as far as the code base goes, and not having special cases in there for the NVIDIA code, and sort of works nicely. So that's been good. Appreciate that.
Oh, yeah. I think that was the goal is over time we accumulated like branches and pretty ugly like path in the front end, and I think the cyclomatic complexity ended up being really high, and like it was impossible to test all the code path, and like there were like many problems, and I think yeah, so now like a lot of the code is shared, and we've tried to keep things very hackable, so third-party backends can still do like whatever they want in their little namespace. So like they can link against whatever library they want. So yeah, so that was the purpose, was to really try to separate different backends, but have a lot of common code. And also like now NVIDIA is also like uses the exact same API as the other backends.
That's good.
Although the refactoring of the C++ code, there's still like a lot of work to do there to make sure like backends don't need to like copy paste unnecessary NVIDIA code. But we're working on it.
So I have a question. You say that there is a way to discover external backend that have been forked. How does that work?
Well, I think it's just within for. I think you can just put environment variable in the setup.py to specify like backend names under directories, but this is intended for use like by people who like fork Triton, so they can be sure that like the things compile. I think if people try to do this on top of the main branch, there's a very high likelihood that the backends they're just not gonna compile most of the time, because we keep changing the command interfaces a lot.
But assuming that that for backend is on the same commit as the OpenAI Triton project, then it should work. Because I mean that means that like we merge pretty often from OpenAI, and so from time to time there are breakages and we go fix them. So if that happened at that point in time, then it should work.
Yeah, I mean if the Triton dependency in the backend happens to be exactly the top of the main branch, then this will work.
Any other questions for Phil? For the backend refactoring?
I guess one comment, like with the AMD backend, you know, we're very happy as well with the new layout. By the way, thanks for all the work. We still have a bit of duplication on the, you know, the conversion, the IR or LLVM IR conversion, which got, you know, we have our kind of the one conversion pass we kind of still control completely in our back end. But this, even there's still a lot of duplication. You had mentioned that maybe there's still some more work we can do to refactor, maybe to reduce that. I'm kind of curious if you have anything in specifically in mind for that. I mean, we can always, we'll roll with it, whatever we decide to do there. Just kind of curious what your thoughts are.
Yeah, I'm working on it. I expect it to take like a few weeks.
Okay.
There's like a lot of things to disentangle, especially with Hopper support.
Yeah.
So I think the first part is like, yeah, to try to have like reusable pattern rewriters essentially, and then each backend would just like include and like use like some generic pattern rewriters that we provide for like data movement ops. Maybe we can have like some level of configurability so that even like you can use the same reduction and scan and histogram converter if you provide like a warp size and a way to do like ballots and pop count, these kind of things. So yeah, I think this will take some time, but this is my main focus. Yeah, currently like the Triton GPU to LLVM conversion is pretty horrible and hard to maintain, and I'm planning to spend most of my time trying to disentangle everything and make things more modular. Yeah, also like I have a PR that's not yet submitted, but to decouple the shared memory allocation from the actual lowering to LLVM by inserting like metadata in the IR. I think currently there's like a lot of statefulness also in the Triton GPU to LLVM, so like all the patterns have to inherit from a base pattern, and there's like a lot of complexity there that like it's unclear what this base pattern provides apart from like access to analysis and like some state that we probably don't need. So yeah, so I'm gonna work hard on trying to reduce complexity on that part of the code where I think is the most of the complexity remains in the project, and then like different backends can, yeah, hopefully the amount of code will be like much smaller for all the backends.
No, that'd be great. Yeah, and it's similar to maybe on the front end abstractions that you implemented, where we can customize our passes, or add some as we needed for in the specific backends, right? So we can customize the patterns there, or do ones that make sense, and others that or not do others. I like that idea too. So if there's, you know, anything we can do to help, of course let me know. But if you've got a design you're working towards, that's fine as well. But okay, yeah, thanks for that. I'm just kind of curious.
Yeah, I think also like a big challenge. It's not like a technical challenge, but when I think there's a risk when we try to remove duplication like this is that like in a sense, it discourages innovation a little bit because you'll be tempted to try to reuse our pieces of code. But sometimes I think if you think really hard, you might think about a better way to code gen for your architecture. Because ultimately this is like things we did for NVIDIA, you know. So I think, and that's the one thing is like we can try to make things generic, but like we have to keep in mind that yeah, you might need like some redundancy can be okay sometimes if it means that we can get better performance because we didn't design the perfect abstractions in the first place.
Mm-hmm. Agree, for sure.
Yeah, Javed, you had your hand up.
Yeah, hi. I'm sorry I missed, I think, the first few minutes. So I just wanted to double check. So the front-end refactoring is stable now and we can try to rebase. I'm from Qualcomm and some of my team also are here.
Yeah, I think so.
Okay, good. Thanks. Second question I had was if we sooner or later wanted to upstream, is there some prerequisites, some things we have to do?
Yeah, I think that's a separate conversation. I think to be very blunt, I think today we don't really have plans to upstream like mobile backends, and I think it would be hard to find requirements for them. I think we're working on like requirements for like backends where that would give us confidence that they're strong enough to be upstream. Then that might be like along the lines of like getting like I don't know, like 1 petaflops FP8, or like in general maybe like 80, more than 80% of what are like the best NVIDIA hardware. I think we want to have like a system where like the requirements take into account both hardware and software. So for example, it's like your backend on the best hardware is 80% of the NVIDIA backend on the best NVIDIA hardware, or something like that. I think today for AMD, I think we're like more or less there. Maybe it's more like 75% on MI300X FP8, but I think we're close enough that like it made sense to put it in 3. But I would expect requirements along these lines.
Can I ask actually? Maybe I don't understand the context. So let's say that for LLVM backend, if somebody was trying to upstream, the performance number were not a criteria for upstreaming. So I'm trying to understand why. What am I missing here?
I guess we're not LLVM.
I mean, like what I mean to say is like, if it doesn't break the system, the performance is a never-ending thing. Why is that a criteria?
Because I think it's like extra maintenance costs, and I think a criteria is also going to be like how. Okay, so a big criteria is like how useful we think is going to be for like AI research. I think ultimately that's one of the things that we're trying to push, because that's where most of the usage of Triton is today, is for AI research. Maybe there's a separate conversation that needs to be had for sampling one day, and that might be like different set of requirement. I don't think we're there today. But if we look at like how useful the Triton backend would be like for AI research, I think even if you have a backend that has like 90% utilization, but the hardware is like 3 or 4 times less power efficient, then it's not going to be 3 or 4 times, but it's like significantly less power efficient than say NVIDIA or AMD. Then it's going to be a lot of work to maintain an upstream backend, and like market share might not be like of the hardware might not be very high. So that's sort of like trying to weigh like the maintenance cost of the backends versus like how much we expect to use it. And on the other hand, sometimes like there might be companies that have like small market share, but that have very good hardware and very good software. And in that case, I think it's totally okay to upstream. But I think the combination of hardware and software needs to be like competitive enough. Does that make sense?
Oh. No, it doesn't, because a company, I mean, there is also the question of your hardware can cost half what NVIDIA provides. And so, some people may be willing to use that hardware, even if it provides less performance, because it's, cost per performance. You have to consider also the cost of the GPU, not just the raw performance. I mean, I can understand that you are concerned about proving that Triton programming model is a good programming model. And so you want to say, well, a backend implementation has to be functional and provide a certain amount of performance. But performance is always going to be measured in terms of percentage of peak. And if your peak is much lower than your competitor, but your cost for that GPU is 1/4, well, it's there are scenarios where people will want to use that kind of like GPU and not the latest NVIDIA GPU.
I think that's fair, although like cost is like not super easy to evaluate, right? Because like I guess it's very clear for consumer GPUs because the cost is like you have the recommended pricing there. For server GPUs, like it depends a lot on volume, I think, that people buy. So that's another consideration. And also like I think there's a case to be made for performance per watt, because maybe like some also like another part of the cost is not just like capex but like opex, and how much power it takes to run. And even if the GPU is like costs less money upfront because the vendor decided to have smaller margins, for example, then it doesn't like translate super directly to like the total cost of operation of a supercomputer, for example. So I think that's true to some level, but cost is like a little bit hard to evaluate.
So when Philip, when you said 80% or some reference compared to reference, I'm trying to understand what's the reference. Like it should be apples to apples. So like even that case doesn't make sense to me. Like so, I mean, if I handwrite something in assembly, I may have great performance in certain kernel. Triton may not give that, but that doesn't mean like, oh, now this Triton backend cannot be upstream because it doesn't match a certain reference.
So I think also I also want to understand like the benefit of upstreaming like versus the cost. I think the benefit, I guess there's a status thing. It's like, oh, it's good to be upstream. Maybe it's like slightly more convenient for the user because they only pip install like a single package instead of two. But like the benefits of upstreaming is like not super
Yeah, I
clear
can give
to
one
me.
benefit maybe, which is like, increases the ecosystem. So suppose, let's say some people looked at ARM backend for certain, I don't want to say LVM again because you say this is not LVM, but what I mean is like, it becomes sort of a reference for other people. So it increases the ecosystem. You know what I mean? Otherwise people think, oh, it can't be done for that backend or that set of hardware, don't know how to do it.
But I mean, like the ecosystem also increases with out of three things.
But from our point of view, Intel GPU is adding to PyTorch as a PyTorch backend, upstream PyTorch, and that create a dependence on Triton. So for them, they would prefer just to pull one Triton with all those backend built-in, all three GPUs, and like leaving us like staying out of tree. Like we have to offer a separate Triton basically to them, so that actually make them integration flow much more complex.
That's manageable though too. I mean, I definitely feel that because like AMD's in that same boat. Like right now, we've got AMD's in Tree and Triton as of last week, but like we've had support in PyTorch and it's manageable. We have Torch wheels. So I mean, just a little bit more work you got to do, but it doesn't like leave you on the cold or anything. Right. So like with the AMD backend, we refactored to the new third-party backend, and we were a submodule link for a few days there, and then switching for it to be in tree didn't really change a lot other than the code is there instead of there. It simplifies the CI, a few other things, but you could still kind of get the code with a git clone recursive or whatever, if it is a module link or either way it ends up going. But there's just a little bit more work. I don't think it leaves everybody out in the cold for any means, right? It'd be good to have a nice third-party backend ecosystem. I agree with that.
I think
But
it's easy for you to say it now because you are in tree. Right, but
what I'm saying is it hasn't changed. It hasn't changed much for us.
Yeah. But when we talk to Meta, right, they would like all stuff to be in tree, so they don't have to change their build script. So certainly it creates this problem, right? For anything that's a third party that's not in tree. For us, the most important one is really the PyTorch integration, and now we have this big obstacle there. And our backend used to be in the third-party folder, and this one removed it, right? Without any discussion, and right, with never take any of our input. I don't think that's good for the open source community, because kind of like OpenAI is picking winner and loser here.
No, but I mean, we could like if it's a submodule, it's going to be a nightmare for all your users. That's what I don't understand. Like, let's say someone wants to install the Triton backend, they clone Triton, and it doesn't compile because we changed like the headers to 5 minutes before. I think I don't even see the appeal for you to have it be a submodule.
Yeah. Let's take the case of PyTorch integration, right? So PyTorch will make the update every once in a while. So it's not like every second they're going to put on a new Triton, right? So essentially, we should have the time to basically fixing any problem on our side that match the Triton version PyTorch is using. So now by removing us from that, right? So now we are forced to actually take a fork of Triton.
No, but that's not even like. I think you can still like discover the backends with environment variables and like I think if it's just a matter of like whoever builds Torch on a particular commit needs to set an env that points to like your Git repo and the setup.py downloads the tarball.
I thought one of the goal of this array arg is actually to prevent diverge of fork of the Triton IR. So that was the stated goal, but the change here seems like a contrary to that, because in that case we'll have environment variable pointing to our fork. That essentially making the diverge more likely to happen.
But you don't, as a point is you don't have to, if you use a submodel, you don't have to fork, and you shouldn't want to fork. That's actually much harder for you to integrate. And the idea is
no. What do you mean by shouldn't want to fork? Because for example, if the OpenAI change your header every time and every second, is break other people's backend. So what is the least path of resistance, right? So that's the path. The path of least resistance is basically taking a fork and making everything stable there. Don't taking anything from OpenAI.
No, that's really not the goal. And
no, it's not a goal, but you are setting up that path of least resistance. So basically, the water will flow through that path.
No, but let me explain the suggestion we are making is whether you're in tree or out of tree. The main difference is who's going to fix the API breaking change. So as you know, IR has to change all the time, and we change the IR. So now someone has to go and fix the backend. If it's in tree, obviously the person that is changing the IR will have to go and fix all the backends. And that's a significant amount of work in some cases, or maybe it's a small amount of work, but it accumulates. Now, if you're out of tree, the change won't break you directly. It only breaks you when you integrate. And when you do an integrate, you're going to pull the latest change of OpenAI. You're going to run your build, run your test. You're going to say, okay, some things break. And you can look at the change, you can see what broke, you fix it, and then you do one commit that updates your submodule plus the fixes, and then your CI is continuously green.
Right. But what if we take responsibility to actually making sure the backend doesn't break? Or let's say 24 hours time, we are basically conforming to the API. So right, that will make us fully update to the Triton, and it also doesn't really take any putting any burdens on your side either. So why should we take a fork and allow this thing to diverge, right? Because for us, we don't want to take a fork. So that is very clear. For us, yeah, that's the thing we want to do. The only reason we want to be in Tree is we don't want to take a fork. So we'll be falling out of date, right? We're not fully in sync with what is going on there.
I don't understand how at the end, it's the exact same development flow for you, because whether like the submodule dependencies in one direction or another, it makes zero difference. Like you can go and pull Triton every day and you'll always be in sync and fix things. It's going to be the exact same code.
So the thing for us is really right for Meta when they do their PyTorch build lightly and everything, right? They will basically build off the Triton tree. So that's the big difference, because all the third parties, we cannot go tell them, say, hey, for Intel, go fork this thing instead of using the Triton official repo.
But okay, so
right,
I think
so now it become like a end-to-end problem for us, because we.
But whenever Meta like compiles Triton, they need to like compile the Intel commit from a green commit, like from like a commit that a Triton commit that passes CI for the Intel backend. And like if things are in tree, we cannot run CI for them, because then we're gonna break CI all the time, and we like the person who makes the
I have a thought of a different approach. Let's say we have a submodule that the repo that it points to actually is a fork. That means it will use that specific commit of Triton, and it's the responsibility of the backend to keep up to date to the latest Triton, but nothing is break. So that will work, and it can be added to the submodule and in the OpenAI Triton repo, and it should still fine. And there's no cost other than you need to review and approve the commit that update the submodule hash from time to time.
It still breaks, right? When Triton moves forward, then the submodule is out of date.
No, because it will, when try to build the submodule, it go inside, which is a fork, then it will use the Triton in that commit that works for them at that moment, which is then the responsibility for the backend to keep merging from the OpenAI Triton to be up to date, but it doesn't break the OpenAI Triton.
There's a full duplicate, you're saying, of Triton basically in the submodule?
Yes.
But that's very, it feels a little backward. One suggestion I was going to make for the meta problem is, can you just fix it in the release branch?
No, we can do it once for one customer, right? But they are so many customers are using Triton. So essentially, right? So basically, they will basically, right? So we want Triton OpenAI to be the single point of contact for them to actually get a target for Intel. So essentially, right? We don't have to go to every customer to say, hey, to build something for Intel, take this fork. Right. So essentially what we try to achieve is for them to always take the Triton repo, right? They will have a submodule linked to Intel target. If they're running into any problem with Intel target, they come to talk to us. So there should be zero overhead on your side. It's kind of like Triton become a marketplace to say, hey, for this product, go to Triton, right? Yeah, just go ahead and pull it down from there and build. So OpenAI is only responsible for the entry ones, the NVIDIA, AMD. For any other third parties, you contact the backend provider.
But what Triton commit are you going to point them to? Like just the top of main, and it just might not work,
right?
They will work
So
because
actually, Theo, that is what we proposed earlier. Like when you create a release for PyTorch, so at that point we need a period of time, like so that we test on our side and we promote a new commit on top of that release bunch.
I mean that's like a detail. Like if the question is like you want like the 2.2.x branch to change the setup.py to accept like the Intel backend, we're totally fine with it. Like I think if you only take like every release branch that we have and make sure that like the Intel backend can be installed from the top of that branch on the Triton repo, I don't think we have a problem with it. The problem is like on top of main.
Yeah. So to actually answer your question, right? We were going to point to main. So probably with like a 4-hour delay, unless we're running into big issues, right? So then we're basically pointing to a specific change set. But that is our right. So that gave us freedom. Also gave all the other third-party freedoms to basically still using the OpenAI repo as the single point of distribution, kind of like a marketplace for Triton. And then we'll be able to update to the one that you have there, because for our own integration, we also run CIs on our side as well. So we do put on every day.
Yeah. So I don't understand how you can guarantee like 4 hours or even 24 hours to fix the issues.
We may not be able to guarantee, but at least that doesn't hurt anything on the OpenAI side. But on our side, it's basically force a discipline to keep in sync to the main as soon as possible. So instead of pointing to a specific release, right, that is a lot of cases going to create more trouble and divergence.
But we're still not going to be able to. I think this is like a little strange. Like sometimes the rebase takes a very long time. Like the AMD backend was like several months behind the Triton main branch, and when I rebased, it took me like a long time to do it, and I broke a lot of things.
We are current with Triton.
We are current, yeah. So it also took us a long time, but we find out if we do it incrementally and as soon as possible, it takes less effort.
So essentially, you want to have an incentive to rebase frequently.
Exactly, and that also forces us to understand what gets checked in there. Right. So it's really depending on the development stage, because when we first started, we have a lot of things to catch up. So we have to freeze it and do it periodically. But now we're up to date. So for us, any further incremental changes for us to integrate is not that hard.
But I think this tracking of what changed, you still have it if the submodule is going in the other direction. It doesn't make a difference. Like you can force saying, I'm going to pull every day, or I'm going to pull every 4 hours, and you still can see exactly what changed.
No. What I said, is really our concern is really all the third-party users of Triton, they want Intel target, So we don't want them to take a fork. We want them to basically, take the Triton mainline from there.
But you wouldn't want them to take mainline, because mainline may be broken, like you don't know.
Well, a lot of customers, they actually run integration tests overnight as well. So they will get a warning sign things doesn't work. So it's not like they will only take a release. right? So I mean, nowadays, I mean, this CI thing is pretty prevalent everywhere, right? Nobody wait for the next release in order to do things, because
but you don't want their thing to break when they don't touch anything. Like if their
right.
thing, like if they're
So
always
basically,
pulling main, like
yeah, but we are also doing it right overnight, and we're pretty soon we're going to do it like a per change set. Whenever you check in something, we will basically put it down and do the testing on our side as well. So yeah, well, I think that's the only way we can keep everything in sync. Okay, so if we take any other approach, right, we will see things will diverge.
Well, there is
create
another
more
way.
trouble for us.
The other way is to be directly in tree. That's the best way, right? To be the code is in tree. We develop directly in the OpenAI GitHub repository, like in many other open source projects that I know about. They're very open about contributors. My opinion, OpenAI would benefit from building a larger community, because yes, I understand there is overhead on your side to you're making some API changes, you're breaking some code in the backend that PR actually cannot go in until everything is green. But the other thing, the other side of the medal is that we can also change your code, and we would be then responsible to fix anything that breaks into all the backend, the NVIDIA, the AMD, and everything else, right? You build a community by being inclusive, not by picking winners and losers, like somebody said before.
I mean, it's like putting in tree. It's gonna be like just additional work that's just gonna slow down development for the backends OpenAI cares about. Like I think
Yeah.
ultimately, like all the core Triton developers that like push like all the commits in the repo and like make language change and add new features, like then we have to like update whenever we make, as you said, whenever we make a PR and it breaks like another backend, then either like we disable CI for that backend, or either we don't compile that backend, or we fix it ourselves in order to merge the PR. And I think that the first thing we tried is like, let's just not, we could like not compile the submodules by default.
Yeah, that's what I was thinking. Like, for new entrants, maybe that would be a way. Like, if you don't trust yet, or it's not matures too much, then you just carry on, but do not stop them from upstream.
I mean, it's like, I'm okay with that. I just think it's like it's worse for you. But if you want that, I think that the problem like I'm seeing is like your backend is going to essentially like break all the time, and like whenever people gonna want to get like Triton from like the main branch, and they're gonna clone Triton and they're gonna install, maybe there's like 50% chance that your backend doesn't compile, given how frequently we change the headers. And to me, like this doesn't seem like a good thing for you, but like from our point of view, like not compiling the submodules by default, or like having them out of tree doesn't change much.
But still, it will be like a version that is like, okay, take that, because anyway, sub-modules, so people there would be points in there, hashes which compile successfully.
No,
it won't be top of trunk. Yeah.
No, because like now that there's shared code, like there might be like no existing hash in the submodule that's compatible with the new Triton headers on main.
Is there a plan to have release branches or stable branches in Triton? Maybe that would solve some of the problems. Like, if PyTorch started working from a stable branch, and then you maybe just put the submodules there, and then main is Wild West, it could be broken. Maybe you could try it there, right? Would that solve some of the problems?
Yeah, I think that's sort of what I was alluding to before. Is I'm also fine. Like right now we have the 2.2 branch. Like someone can make like a 2.0 3 branch or like 2.2.1 branch on top of it, and this will be stable because like we're not touching that anymore. So I think if we had a stable branch, that would be like along these lines, is like whatever latest release we have becomes like the stable branch, like the base of the stable branch. I think having a stable branch that's updated frequently is like very tough.
Or is it, maybe if you had a release branch and then, okay, this says we don't update headers, and at some point there's a life cycle and it's old and you don't use it anymore, and then you eventually cut a new one, right? And that's stable as far as headers and whatnot.
Yeah, I think it's really hard, like especially like
still,
maybe
that's no zero work either.
Maybe it's a place we can be in like in a like 6 months or 12 months, but today like we're like changing things super frequently. Like we found like a number of limitations in Triton that we're trying to fix. There's like a lot of like redundant code, like poor abstractions. I think that the problem is like the moment you guarantee your things are stable, it means you cannot clean things up well. And that's that's a little tricky.
I mean, one thing that can be done is really having frequent like branches that don't get updated, but are saying, okay, they're going to be, they build, they are stable, they pass. And I mean, people can, it doesn't have to be OpenAI responsibility.
Yeah.
People can create them as often as they want. Like you could have them every day. You're saying, okay, I am going to cut this branch, and I know it builds for like all the vendors that cares about it. Can have the submodule, it completely pass, it works, and people pick that instead of picking a random hash that may or may not build that, which feels a bad experience.
Sure. Yeah, that's also a possibility. Like we can have a stable branch that's not maintained by us, and like we can call it however you want, and then like you can have a branch upstream for Intel, in which like your submodule is there, and then like you can make sure it's always green. I think we're fine with this as well. And
yeah, I think
and and you can update it like every day if you want.
Yeah, so but I think that's that is another thing we can figure out. But I think for today, right, the question is really whether OpenAI will accept a upstream from us to basically with a XPU as a submodule in your
this is what we're
backend.
proposing, right? It's like it's just not going to be in the main branch, but it's going to be upstream.
No, we're actually talking about in the main branch. We would like to just have a submodule in the main branch, so it's not maintained by you. So yeah, that is our ask.
But I think that this ask, like in a sense, I could just tell you like it's not my problem, because like if people pull Triton and 50% of the time your backend doesn't compile, in a sense, it's not my problem.
Yeah, that is my problem. Yeah, so we will deal with that. But the only thing, right, we're trying to achieve here is for our customers, they'll be able to basically fork off your main tree. They'll be able to basically pull down your main tree and do the build for the Intel XPU backend.
And how do they know if it works or not? Because
they will contact us. They will contact us. We will run a CI. We will tell them, right, which version is good to basically pull from there. So yeah, that is our ask.
Did you like talk to them? Like, are you sure? Like, are they like? I would be surprised if they were fine. Like, that's
a different thing to worry about, right? I mean, that doesn't give like all the third party the equal footing as you have in your current pick, but at least, right, it gave those backend a real exposure in your main branch, so people can point to the customer to say, right, go there and do that. So instead of saying, right, take this fork and we don't know how close this fork is to the current mainline, customer will ask that question.
No, but I mean, like being close to main doesn't guarantee you can support all the features of main. It's like
Right.
for example, tomorrow we could add like obscure numeric format, or we could add like, we even have like a histogramming op, or like we could add like new complicated ops that are like cogent by like doing just pure inline PTX, and that wouldn't mean that they could like use Triton on top of main and expect it to work on Intel even if it compiles.
That will have the same problem on AMD, and if AMD creates something in there, that will have the same problem that won't working on PTX, right? So essentially, I don't think it is to the Triton community's benefit to basically, right, creating this like a two-tier system. So I can understand the overhead that you mentioned about, right? But I don't think adding a sub module in there is going to create any additional overhead for that. You are basically, right.
No, it's not about the overhead.
I mean, you are basically giving people an impression to say, right, those backends are not officially encouraged or endorsed.
No, I think the submodule discussion is not about the overhead. The submodule discussion is precisely about when someone pulls Triton, they know that every backend that they can compile for is gonna work. And you know, and I'm fine like having I think the best is really to have a branch that gets updated daily by you or like whoever wants to do it, or like you can say like, if it's like a communication thing, we can put a message on the README or whatever. But like I want a branch where people can go to and say like, oh, like I can compile the Triton backend from the Intel backend from that branch. And what bothers me is actually with the putting it in main is not like, it's not about like overhead. It's just like when people like clone Triton, I want them to have a place where they know Intel backend will work. And yeah.
So just, I think the conclusion is, I don't know what the conclusion is, but just pointing out, you're saying that there are certain operations that need to work on every backend for them to be included in tree. For example, you brought up the histogram thing. So
no, I didn't say that.
What do you say
I
there?
said like, I said it's the expectation of something is in main, that like everything
works.
Yeah, everything in main that's there works, and we're not there today, but it's where we're trying to get
because
to.
I was just going to point out that some, you know, according to the testcore.py, you go and look at the histogram test inside there, and there is the thing, it doesn't work for AMD in tree, but it'll work on the fork. So, you know, if you were to say that everything has to work today, then you're not there. Now, if you say that has to be, you know, so AMD is in tree and not everything works for the backend in tree.
I know. I think in a few weeks, in a few months, I would expect everything to get there. But
yeah,
so you know, to play the devil advocate, Intel backend could be in tree, and by the same reasoning, the same logic, exactly the same logic, not everything works.
No, I think
and it will be there in a few months too.
The criteria for in tree, as I said, is like more about performance. Like if you tell me you can get like,
is simply this: OpenAI cares about certain backend, but not others. You know, let's be honest. I don't know why, but that's your criteria.
The reason why is today, MI300X, you can get like 1 petaflops in FP8. That's the only reason why.
Okay, so then if you get like 1 petaflop in another GPU, then we'll be able to be in tree.
Yeah.
So Philip, this is Arak from Intel. So PVC can get 1 petaflop. Are we in tree or not?
Sorry, what can get?
Ponte Vecchio, our GPU can get, Intel GPU Max can get 1 petaflop. Are we in tree or not?
Yeah, if today you have a GPU, you can get a Triton Matmul example, 1 petaflops in FP8, we can have this conversation.
Great. So can we have a follow-up conversation on that to show you the numbers or get you up and running?
Yeah, we can start this conversation, but I think the discussion about like being in tree, it's about performance and like, yeah, functionality. I'm aware like it's gonna take some time to get to parity, but This doesn't solve like the original problem of like submodules for people in general, but we can have this conversation separately.
Great. So let's do a follow-up conversation. So should we contact you directly or through Pavar?
Yeah, you can contact me directly.
Thank you. Talk to you later.
So Phil, about this criteria, how does this work for the CPU backend? Does Triton has a roadmap to include the CPU as an entry backend?
Yeah, I think we're thinking about it, and we're actually thinking about trying to do it ourselves. We haven't started yet, but or like we can talk about having community do it. I think we have some ideas in terms of how we think it should be done. But I think the code structure is not ready yet to actually implement it. So I think we need the refactor of Triton GPU to LLVM to happen first, and then CPU backend can come after. I think in the long term, I think there's a case to be made for it. So so the CPU backend maybe in like 6 months or something, we can start seriously thinking about like how the design is going to look like.
Yeah, we would be very interested to participate, and even we could own it. So, for example, Intel is on CPU backend for PyTorch. Like long term, it's really our interest also.
Yeah. I think the big case to be made for the CPU backend is reducing the maintenance burden for torch inductor, and another case for it is debugging. I think it's going to help the debugging experience. I think that the main thing there is like I think Triton needs to be in a place first where it can generate SIMD code instead of SIMT code, like without too much bloat. And we're not there yet, but essentially the way we do it is like we'd map each warp to like a SIMD unit, and we choose like a warp size of like 512 or whatever. And currently I don't think we can do this without like adding a lot of maintenance burden, but if we keep refactoring, I think eventually we will get there.
Yeah, it is really interesting to hear, because when we do design for PVC for GM performance, we also needed to map to what we call the subgroup level first, so that then we map to the SIMD instructions. So it's kind of we need a layer inside the Triton instead of loading from the workgroup. So, I mean that third block to the each individual third level. We need a middle level. If that you are looking at this point, we would like to understand the design and see we can use the most of your thoughts align with your design.
Yeah, I think it makes sense. I just think it's probably like a little bit premature to actually do it in 3. And it's the kind of thing where I think out of 3 also makes sense. For now, at least.
So Jianhui, you from Intel will contact Phil separately about another discussion.
I think that will be was a separate discussion with Phil.
Okay, and then we had the item about AMD experience. Jason, do you want to add anything there? We have like a couple of minutes.
Yeah, we only have a few minutes, and in truthfully, we kind of talked a lot about all of the topics, really, and maybe we could, maybe we save this topic for next time, I suppose. But like the, yeah, I don't know if we want to like jump into this with 3 minutes left, given all the conversations just now, but I did have a few slides and stuff. But we're gonna run out of time, I think.
That's fine. Yeah, we can do it for next month.
Okay.
We can maybe have it mid-Feb, so in a couple of weeks, and then you
Okay.
can present that. Yeah.
Okay, that sounds good. And then, you know, we'll just carve off a little bit of time then. I'm fine with that.
Sounds good. Does anyone have anything else? Okay. Yeah.
Just to add one. I mean,
Yes. Go ahead,
Philip,
Javed.
and your, yeah, like, you know, have a thought about like, you know, what's the best way for like third party like Qualcomm to have some. Yeah, I mean, we didn't quite answer the questions today, but it's fine. But like, yeah.
Yeah. So
Just,
so I
please
think
keep in mind. Yeah.
yeah, I think for like for third party backends, you know, I hear the concerns around integration. I still think on top of main, like doing everything on top of main is unreasonable for things that are not in tree. On the other hand, I think we can create like a separate branch. Yeah, you can have like a Qualcomm branch, Intel can have an Intel branch or whatever. In the upstream, I'm not opposed to it. And then like if the only concern is like visibility, if the main concern is visibility, I think that would partially address it. Yeah, I think that the only thing we don't want is to have like submodules in the main branch, because this is where things would like break all the time, and like submodules like in a place where CI can run. Like if you have a Qualcomm branch and like the like Qualcomm CI runs on that branch and not on main and doesn't interfere with us at all, I don't really see any good reason to be against it, unless like we'll have to talk more internally and see like maybe I missed something.
Is it,
But like yeah.
maybe an update to the README with links to all these branches, if that's the decision, you know, that'll help with visibility as well, right? So if you go to the third party, maybe there's a README there, like here's the ones that are in tree, here's the, you know, the ones that are community supported, something like that.
Yeah, that's also possible.
Yeah, and I mean that's good. At least it's a compromise, and then there should be some kind of, you know, I think you guys are already working on it. Some, you know, requirement. Now you're in a branch. How do you get into the main branch? What are the requirements that you have to satisfy in order to be considered to be pulled into the main branch, and so on? That may require, you know, performance. I don't know.
Yeah,
I think that it's good to have some kind of, you know, minimal requirement. Let's not shoot for the moon, but you know, something that is not embarrassing for either OpenAI. And you know, talking for Intel, we don't want to embarrass ourselves with poor performance either, right? It's not that we shoot for to provide something that is quality and is high performance as much as we can, depending on our own hardware.
Yeah, I think we will probably have those at some point, but I think that there will probably be like this backends that like will be like de facto extruded. Like for example, I don't think the requirements for the next year, at least for this year, would like include mobile GPUs like Apple, for example. You know, maybe in the future, but I think it's always like trying to weigh the having things in tree. And for now, like we're like mostly focused on like just the AI training, like Triton for AI.
I mean, one concern, you know, just I understand your concern. I also understand that, I mean, you have technical debt in the project due to the fact that you're working a startup mode and so on. At some point, the project is going to become more mature with more stable API. And that will cause, you know, then at that point, you know, pervasive change is going to be less frequent. And there will be less overhead in maintaining more than 1, 2, or 3, or 4 backend.
Maybe.
Yeah, I don't think that's necessarily I mean, the internal IR is really not meant to be stable, I think.
Yeah, there's like a lot of Hopper things, and like every time, and you know, there might be like Intel specific things also that need to be done, like if you want maximum performance. I think it's I personally think it's hard to guarantee this, and also like I do think that like if, as I said before, if people constrain themselves to like reuse or reusable pieces of code, I'm also concerned that like this might like disincentivize innovation to some extent. of like yeah, so I guess we will see like what the project looks like in a year, but I really like to figure out like a out of 3 like backend system or like in branch backend system, like out of main backend system that people are happy with.
Okay.
Okay. Yeah, thank you, everyone. I'll post the notes and the recording. Thank you.
Thank you.
Thanks all. Bye.
Thank you.
See you next month.
Bye.